let us start. And so first actually we'll be starting with the network theorems. Right. And as I said earlier, this is being the orientation class, and what we are going to discuss is, first actually we will have to discuss what is the syllabus. And what is the weightage of this topic. And third one is, what are the fundamentals required to understand this topic. And the fourth one is, what are the previous year questions. Right? And is, what are the books to be followed. Right? So these are all the aspects actually that I am going to discuss it now. And if you wanted me to add any other things, so you can let me know, so that actually I will add it and then clarify it. Got it? And in this actually, first and foremost thing is actually we need to understand what is the syllabus listed by UPSC, so we can plan according to the syllabus. That is one important aspect. And another important aspect is the previous year questions. So this is actually one of the very, very key information, previous year questions, because actually it will give you what is the standard that is expected by UPSC. Because in many years actually I have seen that the standard of the questions that are going to be asked in UPSC Civil Services Electrical Engineering Optional are far higher than the engineering service examination. So be it GATE examination or engineering service examination or actually any other exam you take it, UPSC Electrical Engineering Optional standard is far, far higher. So the questions are actually very, very tricky. And they specifically focus certain areas. And usually the questions comes from only that particular areas, not all the sections actually they target it. For this reason, if questions, you will understanding where exactly we need to focus. So rather than wasting time in all the aspects, it is essential to focus where exactly is UPSC focusing it, right? So that is the reason actually we have to go through the previous year questions, so that what we can do is we can plan the preparation accordingly based on the syllabus and based on the previous year questions. Rather than the syllabus, previous year questions is very, very essential. And obviously, what is the weightage that is expected for this particular subject, that also we have to be aware. And what is the complexity that is involved in this particular subject, that also we have to be aware, right? Now, let me explain the complexity before actually going through this, all these aspects. From UPSC perspective, let me explain the complexity that is expected in electrical engineering optional. So electrical engineering optional, no doubt it is a tough optional, right? So that you take it for granted, but don't be scared of it. Got it? So it is a tough optional. There is a reason behind that. The reason is, earlier actually almost every all India topper used to have electrical engineering as one of the optional. Almost every all India topper before 2010 actually it used to be the case. Then actually UPSC renewed all the syllabus of UPSC and the examination pattern. Especially actually if you notice, UPSC, they don't change the syllabus quickly. And what they do is actually, they usually do the paper pattern change. Pattern change from outside look actually, it is seems to be the same. But internally actually, they make a lot of changes. Let me explain what are the changes. So we will compare with three different options. So first actually, so we will take physics optional. And the second one actually we take maths optional. And third one we take electrical engineering optional. And this is very easy optional. When compared to all these, this is a moderate optional. And this is the tough optional. Right? So even if it is tough, then actually why do we need to look at electrical engineering option? That also we have to be answering it, right? So even if it is tough, why we have to opt for this is we spent already 4 years. Right? We spent already 4 years. Then actually what is the advantage? Obviously you will get a very big advantage. You have already spent 4 years. Then actually preparation will be, obviously preparation is only review. That means you have already gone through the syllabus to an internal depth level. So what we need to do is actually we have to revise everything and some extra topics actually that we have to be preparing, because actually electrical and electronics engineering. So usually electrical and electronics, usually we call this as EEE, electrical and electronics engineering optional. And another is actually ECE, right? And out of you people, and so EEE, how many people are there? Ashish, are you from EEE or ECE? ECE. And Dakya Naik, what about you? ECE or EEE? Right, EEE. Okay. Anyway, good. So the thing is actually for EEE people actually it's a more advantageous when compared to ECE people, and ECE people actually have the equally advantage but not as great as EEE. The reason behind that is, so EEE people actually will have to study extra topics, that is the analog communication and digital communication. Digital. Analog and digital communication actually we will have to study. And in addition to that, EMTL, these people have to study. But EEE actually also involves EMTL subject. But the thing is actually whatever we study in EEE, that is of not much of useful for UPSC, because the standard of what they study in EMTL is very, very less for EEE people. For ECE people actually they study enough. So this standard is enough for ECE people, because till Maxwell's equations actually we study in EEE. But Maxwell's equations onwards actually ECE people will study, and UPSC exactly focus only Maxwell's equations onwards. But actually the basics also should be there for ECE people. So that's actually EMTL actually is extra subject in case of EEE, because what we don't study we have to study it here. And analog communication and digital communication anyway you have to study. And also actually in-depth knowledge of this analog electronics and then actually IC processing, fabrication techniques, all those things actually we will have to study in case of EEE. But for ECE people, all these subjects actually are already done. But what we need to study extra is there are some core subjects, that is electrical machines, energy conversion. So this is what we call as the machines, right? Electrical energy conversion. And another is actually power systems. Power systems. And third one, what we need to study is power electronics. And fourth one is not a subject, it is just a subject, sub-subject, and this is power system protection. So these topics actually for ECE people, all these topics are new, but we will have to study. But the problem is actually power systems and electrical machines are actually not that easy subjects. Unless you take the coaching, it will be very tough to understand those subjects on your own. You need to be guided by somebody. Otherwise, actually, it will be very tough to understand these electrical machines and the power systems, because these topics actually a little tougher. You need a lot of mathematical knowledge, you need a lot of analytical knowledge, and there is a lot of fundamental knowledge that is required before actually attending all these classes, right? So that's the reason actually for ECE people, for sure you need coaching. There is no other way, because these subjects are not that easy. For EEE people, it's okay. So only communication part is there, right? But the thing is, digital communication is having the highest weightage. I think around 90 marks actually, digital communication actually used to get it. Though it is a simple subject and the small subject, but the weightage of that topic is more. and even the analog electronics. So that used to carry around 70 marks, analog electronics. Because in EEE, right, we don't study that depth, the analog electronics, and that carries 70 marks, right? So like this, actually, the weight is also equally given for EEE and ECE people. So that's why actually it is a level playground only. It's not actually very easy for EEE and not very easy for ECE. So it is a level playground for both of these people. Because actually some subjects are tougher for ECE people, some subjects are tougher for EEE people, right? So this you have to keep it in mind. And here why I call this as a level playground is, and when we compare with all these three optional subjects, and we used to have the paper pattern like this. So that is, we have the paper 1 and we have the paper 2. We have the paper 2. And in paper 1, actually, we have section A and we have section B. And in section A, we have question number 1, question number 2, question number 3, question number 4. Similarly, question number 5, question number 6, question number 7, and question number 8. So this is how actually the questions will be there. And each question carries 50 marks. So this is for 50 marks, and this is for 50 marks, and this is for 50 marks, and this is 50, and all these things actually 50 each. And there is a choice for this. So this is also for 50 marks. And the choice is, right, and you have to answer for 250 marks. So there are certain key points that you need to understand before actually writing this examination. The key points are, one is actually you have to answer only for 250 marks. Right? Your paper will be set for 400 marks, but you need to answer only for 250 marks. That means each question carries 50 marks. Actually, you have to answer 5 questions. Right? And the condition for these 5 questions is, you have to answer mandatorily question number 1. You have to answer mandatorily question number 5. And then actually, you need to select 3 more questions, right? Because you need to answer for 5 questions. And out of 3 more questions, at least 1 question has to be selected from each of these sections. That means you can select 1 or 2 questions from here and 1 question from here. Or you can select 2 questions from here and 1 question from here. Like that, actually, you can select it. But you cannot select all the 3 questions from one section itself. So this is a rule. And if you do that mistake, they won't allocate marks for that. So 50 marks will be cut straight away if you make that mistake. So that actually you have to keep it in mind. And another important point is, many of the people actually will do this mistake. What kind of mistake they do is actually, so question number 1 they answer and question number 5 they answer, and then actually you have to answer 3 more questions. Then actually you started with question number 2, and then actually you answered. So again, actually this question will contain A, B, C, D sections. Sometimes actually C, or sometimes it may be C, D also, it will be there. Let us say you answer for A, B, C, and then actually you felt that 4th question you are not able to answer it. Then actually you thought of moving to another question. So you selected these 2 questions and then actually 1 question from here, assuming that. So you will get, so let us say you got 30 marks for this, and you got 40 marks for this, and you got 45 marks for this. And then actually you got, let us say, 50 marks for this, let us say. Then actually this actually, let us say you assume that you got 50 marks here and you got 50 marks here. Then actually you are expecting that, so 50 here, 50 here, 50 here, total 150. And then actually highest they take it, and then 40 and 45 you are going to get it. So 50 plus 50, 150, 150 plus 40 is 190 plus 45 is 235. So you are assuming that actually 235 marks actually you are going to get it, but they don't do that. So what they do is, so here actually they strike off this, and they take these 2 questions, and then actually they will consider these 2 questions because they go in a serial manner. And here actually, if you don't want this question to be considered, you need to strike off clearly, right? So for UPSC, you should give the target that correct only for 250 marks, and you select those 250 marks. So just don't leave for them to select the questions, because actually that is a condition that was clearly written by UPSC instructions. So you yourself has to select the questions and then give it. Other things actually you need to clearly strike off. And this mistake actually you shouldn't be doing it. Most of the times we do. Sometimes actually, let us say you answered only for 10 marks and then actually you continued this way. They consider only this 10 marks and this 40 marks and they ignore this because they go in a serial way. And the last question actually they will ignore it because actually this anyway shouldn't be considered. Got it? So that way actually you have to keep it in mind. Now the complexity comes. So officially they say that there is a choice. For electrical people, surprisingly, there is no choice. Why it is not a choice is, so in case of physics optional, and in the first question actually what they do is question number 1, and they used to have actually, let us say 4 topics and 4 topics it was divided. Like section A actually we used to have 4 topics. Section A 4 topics. And section B 4 topics. Because UPS actually lists, let us say 8 topics they listed, and out of the 8 topics they divide clearly like this. And section A, you used to get the questions only from these 4 topics. Question number 1 will contain A, B, C, D, sometimes E also. Each will be allocated 10 marks, 10 marks, 10 marks, 10 marks like this. And then actually from each of the topic actually they select 10 marks minimum. And one topic will be given a better weightage and that will be given for 20 marks. But here actually, so you need to consider that all the 4 topics are given a chance to get participated in the question number 1. Same is the case, these 4 topics actually, question number 5 actually, they will get the questions from all these 4 topics. Alright, they will get the questions from all the 4 topics involved. So then actually question number 1, so question number 2, it is purely from one topic. So this is only one topic. Question number 3 purely from topic number 2. Question number 4 purely from topic number 3. So sorry, 3. Like this actually they used to clearly give the priority one topic, one question specifically. So indirectly what it conveys is, if you ignore one particular topic, then for sure actually you can take that as a choice, because actually anyway you don't want it to answer all the 8 questions, right? So you can simply ignore 3 topics, assuming that only 10 marks were left over. Remaining all the questions actually you will be able to answer with a better weightage, with a lesser preparation. Because actually 3 topics clearly you can excuse it. You don't need to prepare all those 3 questions at all. Got it or not? That kind of flexibility is there in the case of physics optional, but not for our electrical engineering optional. That you keep it in mind. And in case of mathematics optional, what they do is, here they will mix the questions here. That means all the 4 topics were set for question number 1, all the 4 topics for question number 2, all the 4 topics for question number 3 also. So this way actually there is no choice in case of mathematics also, because every question contains all the 4 topics. Then actually which topic you will ignore? You will never, right? Obviously, right? So all these things actually it will take effect into it, because actually your preparation has to be 100% whatever the syllabus that was listed by UPSC, not like physics optional, where actually they can select the topics, assuming that they can ignore only these 10 marks and 10 marks here, and remaining questions actually they will clearly be able to answer it. But mathematics actually is not like that. The questions were mixed between the sections. So in the one section, all the topics were mixed. And the toughest is electrical, assuming that what they do is, let us say 8 topics, so 4 topics for section A and 4 topics for section B, and any question can come with any of the topics of out of 8 topics. Be it section A or section B, it doesn't matter. They can mix question number 1 from topic number 1, question number 2 from topic number 5, and question number 3 for topic number 7. Like that actually, they can mix any random topics of out of these 8 topics for any question. Hope you got it, the complexity. That means section wise is there in case of mathematics, but in case of electrical engineering optional, 8 topics together actually is treated as a single set, and 8 questions will be set out of these 8 topics. Randomly they can select any particular part out of A, B, C, D sections, A part from topic number 1, B part from topic number 2, C part from topic number 3, and D part from topic number 8, and E part from topic number 7. Like that they can do it. So any question actually they can do any kind of combination. Got it? I hope you understood this. Is this understood? Right? So this level of complexity is there. Obviously actually you have to prepare accordingly. So only advantage what we have got, or actually we can say 2 advantages in case of electrical engineering optional. One is So 4 years we already spent in graduation, because the same topic actually we already studied. Then actually what else we need? So if you are actually clearly planning for UPSC, then from first year onwards actually you start preparing this electrical engineering optional, so that actually parallelly your preparation will be completed. On the go itself actually it will be everything completed. So this is one advantage. And the second thing is actually you can get very good score. Because this kind of advantage is not there for other options, and this is exactly the reason many of the times actually electrical engineering optional people used to top the examination many of the times. And UPS actually clearly they will be reviewing this exam pattern and the questions and everything, and they will clearly instructions for the professors actually whoever is setting the question paper. And if one particular optional subject is keep on topping, then actually they will change the pattern of that. So like that actually before 2010 actually almost every topper actually from electrical engineering background. So that's the reason actually and in 2012 if you notice public administration actually slapped like anything, because actually every person actually used to top with electricity with public administration as one of the optional. Then actually in 2012 actually all the public administration people actually got very less score, and then actually people started spreading across all the options. Then actually geography, political science and sociology, these kind of options are actually nowadays flourishing, right? So like this actually they will assure that actually each and every optional gets equal priority. So that is the intent actually they are going to do it. And this is one important aspect actually that you need to understand. Got it? And one more important aspect also you need to understand of UPSC philosophy is, so UPSC philosophy always lies this way, right? So what they do is they give you mostly the applications. They give you the questions on applications and numericals. Usually they don't give any derivations. Usually they don't do this, right? Very rarely actually they will give you the derivation part. Most of the times actually numericals they will give it. That is one important aspect. And another important aspect is, and here actually they target the applications, meaning the fundamentals if you know very well, then only you can solve the application level problem. So that's why actually they list down the syllabus entirely each and every aspect, but actually finally they give the questions only from the applications. So that means the basics actually they don't ask. So that is actually network theorems straight away, definitions, all those things actually they don't ask. Straight away they will give you very big circuit and then they will ask you to solve with the help of the network theorems. That is how they used to give it. So unless you have the knowledge of all the network theorems, then actually it will be very tough to solve such kind of problems. So like this actually they will target only the application side, not the fundamental side. So fundamentals are assumed to be known, because actually you are so you are declaring that this is my optional subject, meaning I'm expert in this particular subject. Obviously you will be tested on the expert level knowledge. So expert level knowledge is only the applications, it's not the fundamentals. Fundamentals you have to be aware already. Got it? So this philosophy UPSC clearly follows. I have seen both in electrical engineering optional and the mathematics optional. In both the cases actually they will target only the applications, not the fundamentals. So that you have to keep it in mind. But while listing out the syllabus, they will give you each and every fundamental aspect. So listing is everything, but given only applications. So this philosophy you have to be clear. Right? What is the concept of scaling? Right? So most of the people actually used to ask this question, and here actually it has to be a level ground for everybody. So that is the goal of this scaling concept, right? So not officially declared, but actually most of the people actually based on the understanding what we have it, right? What we can comment is, see this. So suppose actually assume that let us say there is one let us say public administration paper was very, very easy. And then actually almost everybody used to get actually 500 out of 500 actually they used to get, let us say, 450 above. Then actually mathematics people or like electrical engineering people and they got very tough paper, and then actually getting 250 marks out of 500 marks actually is very, very tough. Now, in such case, actually, this paper was tougher and this paper was easier. So, people actually who got 250 marks in case of mathematics are almost at par with everybody who scored 450 there, right? Because actually this paper was tougher and this paper was easier. Now, actually, you have to scale up each and everyone so that actually they are on the level playground. For that, what they do is the standard they are going to take it is, suppose if you take the class average, and that class average actually, let us say 450 there, and this class average actually is coming out to be 250 there. Then actually they will try to equate this 250 to that 450. Both are actually one and the same. And this way actually subject wise actually they will normalize it. And suppose if you are on the higher side of the ground, that means suppose, see this, let us say the people are actually distributed like this. Meaning most of the people actually got this average. And most of the people got this average, meaning let us say actually 250 marks actually is the class average, and almost 90% of the people are on this particular side. Now let us say few people actually got very good score and they got actually 300 marks, and very few people will be coming there. And then actually few people got almost actually very small score, let us say 100 marks actually, usually people will get it. But 90% of the people actually got 250 marks. And if you take another graph, and let us say, and this is the graph, and here 450 marks here, and then actually few people actually will get, let us say 475 also people got it, and here actually many people got, let us say, so 400 marks this way, right? Now actually this average and this average actually should be equal, and whoever is on this side, they will be given better weightage, obviously, right? They will be given better weightage. And here also whoever is on this side actually they will be given the better weightage. Now, how deviated from there? So that is also very, very important. How deviated meaning, suppose actually if the graph is used to be this way, right? Then in this case, actually, the people actually who got the score here are extraordinarily talented, obviously, right? These people actually got extraordinarily talented because actually they are maintaining a gap even if it is very tough. 250 marks implies that actually the subject was very, very tougher. But actually, even then, actually, they got very good score. Let us say, in this context, let us say they got around 300 marks. Then obviously, or actually 320 marks, let us say. Then actually, don't you see that these people are exceptionally good? Got it or not? Right? So, maintaining the gap between the average, whoever on this right side, they will be given a better weightage irrespective of whatever may be the class average. So, according to this 250 equated to this 450, and let us say another one actually got, let us say, 3, so let us say 370, and all these averages are actually again they calculated the standard deviation, and based on that actually they will come up with a number for each and every optional subject, and that actually will be scaled up and scaled down. On these people, if somebody is there on this side, they will be scaled down. If the people are on the right side, they will be scaled up depending upon the class average. This way actually they will give equal priority to each and every optional. Got it? Right? So this actually you can consider it. Right? So this is about the UPSC philosophy and what we are going to study. Any questions on this? You can ask me now. Right? Okay. Fine. Now actually let's come back to our discussion. So we were first actually in the case of network theorems. So what is the syllabus? We will list down. First we will list down the syllabus. Now let me open the syllabus. Right? Okay. So circuit components and network graphs. Circuit components network graphs. KCL, KVL, circuit analysis methods. KCL, KVL, circuit analysis methods. Circuit analysis methods. Nodal analysis, mesh analysis, basic network theorems. In this actually nodal analysis, mesh analysis, network theorems. Network theorems and applications, transient analysis. Transient analysis. RL, RLC, RC, RL, RC, RLC circuits, sinusoidal steady state analysis, sinusoidal steady state analysis, resonant circuits, coupled circuits, balanced three-phase circuits, two-port networks. All right, two-port networks. Right, so this is the complete syllabus cycle that was listed by UPSC, and if you notice carefully, so the syllabus is circuit components, so basic circuit components like active circuits and the passive circuits, and in that actually, so we will be discussing about different circuit components like R, L, C, RLC, and so the batteries, all such kind of things actually comes under the category of circuit components. And then actually network graphs. So graph theory is actually one particular concept, and that will be used actually when we try to automate the circuit analysis techniques with the help of the computers. So in that case, actually the graph theorem, graph theory actually it will be useful for modeling the circuits. So there are actually certain techniques actually that will be used, and that graph techniques actually we will be using in this particular context. And KCL, KVL, and KCL, KVL actually this is very fundamental. We start using these concepts from 10th class onwards, and those are actually very basics. So that actually we will be studying it, and with the help of the KCL and KVL, we will try to solve some DC circuits here. And then actually, so in the circuit analysis methods, there are different techniques. One is the nodal analysis, and another is the mesh analysis, but both are derived from the KCL and KVL techniques only. And then actually, we'll be using network theorems. There are certain network theorems which you people already aware, like Thevenin's theorem, Norton's theorem, and superposition theorem. Like that, actually, there are certain network theorems, and all those network theorems actually we will be discussing in this case. And applications of these theorems to solve any particular circuit, right? And then actually we will be using the transient analysis, and this is actually a DC transient analysis and AC analysis. Actually, we will be doing it. So mostly actually we will be discussing only the DC transient analysis, and that is one of the very important subject. Why? Because actually not just from the circuits perspective, it's more from the power electronics perspective. Because in power electronics actually all these transients only does matters a lot. So the main difference between the network analysis and the power system, so power electronics is, we will be discussing the transient analysis separately, And so here in the case of power electronics, that is the main subject, right? Transient analysis actually only some portions actually we will take it here. Now there actually the entire analysis is only the transient analysis. So not only with the DC, we will include AC there. So there actually, if you notice here the syllabus, and sinusoidal steady state analysis is part of our syllabus. So in case of networks, it is sinusoidal steady state analysis. So if you add transient for plus transient, if you add it, then that will be the power electronics. Sinusoidal steady state and transient analysis is otherwise called as simply the power electronics, right? So nothing more than that. So we will be using only the circuit analysis there, right? And then actually, so in case of tangent circuits, we have RL, RC, and RLC circuits. And obviously, I think there is some more portion. Resonant circuit should be there, right? Yeah, before coupled circuits, there is resonant circuits. That's it. Yeah, resonant circuits I have written. No. Right? Okay. Right. So, and then actually RL, RC, and RLC circuits. And then actually resonant circuits. So this comes actually only in the case of RLC circuits, which is a sub part of that. And then actually the coupled circuits is also one of the confusing topic. Many people actually will get confused, right? So network theorems actually in only DC or even AC also. But application wise, actually you can do any kind of analysis for the network theorems. But actually the problems and whatever the syllabus that was listed for us is only the DC analysis we do, not the AC. Got it? But alternating circuits actually we will discuss it. That's not a criteria. Got it? And then it is so resonant circuits. In case of actually balanced three-phase circuits, actually we were discussing it, right? So balanced three-phase circuits. And here actually I will give all the fundamentals that are required for AC, and the fundamental difference between AC and DC, all those things I will discuss. So not just limited to the syllabus, I will go and discuss many other factors also, so that actually you will be completely understanding the topic. And here actually my philosophy is a little different. So what I do is actually, I don't study every subject as a separate unit. Rather than that, if you study one subject, that knowledge should be at least 50% of the syllabus of other subject also should be covering it. That means by the time you start that subject, almost everything should be known. That is how actually you should be planning for that. Then only actually you will get complete command on the subject. So this way actually what I do is, along with this particular syllabus, what I do is, I will discuss ordinary differential equations and Laplace transforms. Equations, Laplace transforms. Right? And these things are actually very, very essential in understanding the subject. Why? Because these subjects actually will cover you a lot of electrical engineering concepts. Only the ordinary differential equations and the Laplace transforms. If you study most of the subjects, meaning one is network theorems, or sorry, network analysis, power electronics, control systems, signals and systems. Just all these four topics actually are just dependent on these topics. If you understand this mathematics behind that, then actually all these subjects actually you will not find it tough. All these subjects are actually straightforward, very, very easy, and it's like a cakewalk. So you need actually only very base level physics concept. So if you are aware of the KCL and KVL, and rest of the thing is only the ordinary differential equation concept or actually Laplace transforms concepts. So only those things actually we will be using it, and then we will be solving it. Signals and systems is purely a mathematics subject. And then actually power electronics actually, as I said earlier, so transient analysis for both AC and DC actually, that is the part actually what we are going to study as part of this power electronics, nothing more than that. Purely the transient and steady state analysis of DC and AC, that is the power electronics. And for that actually, the 100% knowledge that is required is only the power. So this is the ordinary differential equations and the Laplace transforms. And here actually we need to understand what is the relation between the Laplace transforms and the ordinary differential equations, how these are related to our own analysis. So for that, actually, first you need to understand what is ordinary differential equations. So ordinary differential equations are just actually a differential equation. So, but why this differential equation comes into picture? If you notice, most of our engineering background lies with calculus. So almost actually 90% of the time, actually, we will be using only the calculus to solve any engineering problem. There is a reason behind that. So the reason is any problem statement made with few words. So any problem statement made with the terms moving, changing, oscillating, time varying, right? So can you think of any engineering problem without having these words? Can you think of any engineering problem without having these words? Right? Obviously no. So no problem statement can be made without using these words. But wherever these words involves, the mathematical model of that particular problem statement is always a differential equation. So any problem or any engineering problem involving these words, the mathematical model is always a differential equation. Is always a differential equation, right? Why this is coming out to be a differential equation is a differentiation. So by definition, differentiation is a relation between the changes of the variables. Right? So that means, suppose actually if I say that dy by dx, meaning for a change of x, so for delta x, the corresponding change is delta y. So x changes to, suppose x becomes x plus delta x, then obviously y becomes y plus delta y plus delta y. That means this dy by dx, for how much change in x, how much is the change in the value of y. So that relation actually we call that as a differentiation. So obviously when we talk about any particular engineering problem, and we always talk about some kind of change, especially in our electrical engineering, if there is nothing changing, time changes, right? Obviously we were talking about only the time change, always the time change actually we were talking about, be it is network analysis, control systems, or power electronics, or whatever may be the subject you talk about. With respect to time, actually, we draw the graph. So time always continuously changes, right? So that is the reason actually every mathematical, so every engineering problem of electrical engineering is always a differential equation, right? So that is how actually you can conclude it. That means obviously we need a deeper level of understanding of these ordinary differential equations, obviously, right? And you should be knowing all the techniques to solve the differential equation so that actually finally you can arrive at the solution which you can comment it or which you can conclude it, right? So these things actually, differential equation actually is the one actually which we need to understand. And if you notice in entire networks or the control systems, you can see always actually S is the letter actually most of the times actually we notice in any of the textbooks of networks or control systems or even the power electronics, right? S is the letter actually we are going to use it, right? S actually, the beauty of this S is a differential equation converts into an algebraic equation or a polynomial equation. So that is the main reason actually, that is the only application of this Laplace transform. So the greatness of Laplace transform is just to solve the differential equation in a better way or in an easier way. So this is the only advantage actually we are going to get it. It gives you a beautiful technique to solve the differential equations. So essentially, the background is differential equation only, even for the Laplace transforms also. Got it? So that is the reason we will focus more on the differential equations and the Laplace transform. We understand carefully and clearly, then we will actually start the topic. Now, actually, if you notice, why it is very important for us. As I said earlier, there is a continuous change in the time. That is the reason actually we will have to study the differential equation. Let us see one practical example. And suppose if you take a simple RL circuit, there is a resistance, there is an inductor, let us say there is a battery here. So the battery is V and this is the resistance R and this is the inductance L. Now the physics says that inductance actually is having a nature that it will always opposes the change of the current flowing through it. How that is going to happen? So that actually it comes from many other factors, right? So Ampere's law, circuit, so all those things actually we will be using. The magnetic field induction by Faraday's laws, all those things actually are the physics background. But what is important for us is the basic nature of an inductor is basic nature of an inductor is it opposes the change in current flowing through it. It opposes the change in current flowing through it. Suppose if there is a current of I that is flowing in this, and let us say if this is a time varying current, obviously it has to be I of t, meaning I is a function of time which changes with respect to time. But DC actually it will never change, right? So DC actually is a constant. But here actually we represent this as I of t, and then actually the voltage drop across this, the mathematical model, if you do this, then this will come out to be L into di by dt. That is, by definition of the inductance is, see this, the voltage across the inductor is proportional to the rate of change of current through it. Rate of change of current through it, right? So this is the basic nature of an inductor. So here, obviously, the voltage across the inductor is proportional to dI. Now, every proportionality can always be replaced with a constant with equal to sign. V what we do the inductance. So this is the inductance. L di by dt. So that means the voltage across the inductor actually it was expressed as a function of time. But DC actually we always say that this is a constant current, right? So in that case actually do you see that there is a di by dt value? Because derivative of any constant is always 0, right? And here actually we are saying that there is a di by dt that exists, right? Can anybody comment it? Any comment? DC is constant current, right? Why we are talking about di by dt? Because it is anyway 0. Right? Okay. Here, see this. Suppose if you wanted to reach 100, you always start with 0, right? From 0 onwards, actually, you will have to reach 100. Now here, when we talk about the di by dt, even for a DC source here, what we do is, if you try to draw the graph of this or whatever it may be, so when you switch on it, the current actually will try to raise and then actually it will try to take some time, obviously. All of a sudden, actually, it won't go like this. At within 0, actually, you cannot go the current from 0 to 100, right? So it will take certain amount of time, maybe microseconds, maybe nanoseconds, but definitely it will take a certain amount of time. Now, here the transient comes actually only in this particular region where there is a change in the value of current. So if this is the current I of t, so the current actually is changing from here to here. It is reaching finally 100. But until this point actually it is taking certain amount of time. So this is the time actually that was taken to raise the current from here to here. But here onwards actually the inductor will not have any impact. Inductor will not have any impact because it is anyway DC. So from here onwards actually as it reaches already the final value, then actually it will not have any impact because di by dt is 0. So let us say this is 100 and derivative of the 100, which is a constant, is 0. That means inductor will be having any voltage across the terminals once the switch is on after some time. So that means initially it will have a huge impact. This portion actually the inductor, when the current is rising like this, that time actually this will show its own impact. And resistance actually it is always a constant. That means actually it will not oppose the current, and it will allow whatever the current that is flowing, and it will drop certain amount of the heat over there. So during the initial time actually it will have the impact. Once it reaches, then actually it will not have any impact. It can be treated as if like it is a short circuit straight away. No voltage across that. Purely this entire voltage is dropped across this resistance, and there is no voltage that is coming across the inductor terminals because there is no di by dt value. Now you wanted to model this for the complete behavior. You wanted to see what exactly is happening even before actually raising it. So from here to here actually when it is traveling, so what is the impact? Because actually that is the transient impact is very, very essential for us. Suppose actually there is a fuse actually that was designed for only 1 milliampere. Because of the di by dt actually the rate of change of current actually it's happening in a huge way. Let us say sudden there is one spike actually that is coming out, but only for a fraction of a second. Then afterwards actually it will be stabilized to very small current. But that spike actually it causes the fuse to blow off. So initially what is happening, that also we have to be aware. So that means from 0 onwards, or time equal to 0 onwards, we have to know the complete behavior until t equal to infinite, so that we can completely analyze that particular circuit for the analysis purpose. Or actually if you wanted to design any circuit or any switch or anything, if you wanted to design it, then you need to know the complete behavior. So that will be known with the help of our own same differential equations. Now let us see how we are going to see that. Suppose which is a DC source, that means which is a constant voltage, right? The constant voltage is already present. Let us say it is 100 volts. And 100 actually already it was acquired across. It is not raising from 0. When the battery was charged, that time actually it was raising. But now actually 100 volts battery, it was taken and straight away connected it there. And there is a resistance of R here. And there is, right? Okay, fine. So what I'm saying is, see this, we have taken a RL circuit. In the RL circuit, there is a resistance R and there is an inductor L. Now the voltage across the inductor is LdI by dt, because this is the physics behind that, which says that the voltage that is going to be dropped is equivalent to L into rate of change of flow of the current. So that is L into di by dt. And IR is the voltage drop across the resistance. So IR plus LdI by dt is equal to the voltage source V. So that is IR plus LdI by dt equal to V. And this is the one actually which we will be using it. If you notice carefully, this is a differential equation because it involves di by dt. So this is what is a first order linear differential equation is. We will try to understand what it is. Suppose I have a differential equation. Other function of x. This equation is called as a linear differential equation. So this, right? Okay. So this is what we call as the first order linear differential equation. So the nature of the first order differential equation is, so there has to be one dy by dx and there has to be one y, and remaining has to be simply functions of x alone. So this is the basic nature, and there shouldn't be any multiplication of y and dy by dx. So the conditions are, has to be only one dy by dx and only one y. So this is the basic thing of a linear differential equation, and remaining has to be functions of x alone. x alone. Remaining is should be function of x alone. And then actually there shouldn't be any multiplication of y and dy by dx. There shouldn't be any multiplication of y and dy by dx. And the power of these variables also has to be 1. The power of y and dy by dx has to be 1. Right? Has to be 1. But x can be any function. Any random function. There is no limit on that. And this kind of differential equation is called as a linear differential equation. So that is dy by dx plus some function of x into y plus some other function of x. And this is called as a first order linear differential equation. And the solution of this differential equation is, so straight away actually finding out the solution is not that easy. But there is one mathematician called Leibniz who guesses the first time the solution of this. Leibniz. So Leibniz actually, he could able to guess intelligently the solution for this one. Right? So Leibniz, that's why actually this is equation, actually we call this as the Leibniz equation. So this is called as the first order linear differential equation or Leibniz equation. Both are one and the same. Right? And the solution actually what he guessed is, suppose if I multiply this entire equation by a factor e power integral p of x into dx into dy by dx plus p of x into y into e power integral p of x into dx is equal to q of x into e power integral p of x into dx. Right? So he multiplied this entire equation by e power integral p of x into dx. And this way, if you multiply it, then actually it will be reduced into a beautiful format. Let us see, if you notice, this is the left side part, is the differentiation of, so this is d of y into e power integral p of x into dx. So this portion, if you try to differentiate it, see this, if you apply the UV product rule, so derivative of y, so first portion is y and the second portion is e power integral p of x into dx, and dy by dx into this one. So you know this formula, right? So d by dx of uv is equal to u dv by dx plus v du by dx. So this is what I call differentiation product rule. And this product rule, if you notice, the derivative of one variable, that is dy by dx, multiplied by the second one, and then y multiplied by the derivative of e power integral p of x into dx. So e power integral p of x, so this is, as it is e power x derivative is e power x itself, that's why e power integral p of x dx as it is coming. And the derivative of this top portion, e power portion, actually you have to take the derivative again. For that actually, p of x, so integral and the derivative will cancel it out, and p of x actually will come out here. So this is the derivative. So this entire thing actually can be written in this particular format. I hope you understood that. Is this understood? Right? So then actually right side portion is as it is. Now actually, rather than every time writing e power integral p of x into dx separately, we named that as an integrating factor. So integrating factor. So integrating factor if equal to e power integral p of x into dx is called as an integrating factor. By definition, what is a integrating factor is the factor with which if you multiply the differential equation, if it comes out to be an exact equation. Exact meaning So d of something, if you are able to write it, then you can simply integrate it and then actually remove the d. So d of something, if you are able to write it, then that's what we call as the exact differential equation. So here, the factor with which if we multiply, the factor with which if we multiply the differential equation if it becomes exact, then that factor is called as exact differential equation. Exact differential equation. Here the integrating factor is e power integral p of x into dx. So if you are able to write in the form of d of y into e power integral p of x into dx is equal to q of x into e power integral p of x into dx. So this actually we can integrate on either sides. So y into integrating factor is equal to integral q into integrating factor into dx plus c. So this is the solution. Got it? So this is a standard first order linear differential equation solution. Why I have given all this proof is this is the only differential equation which will completely dominate the entire network analysis. So you have to be aware of all these things, right? This is the only differential equation we will use completely in the first order equations, or actually if you use RL, RC or RLC is a second order equation, RL and RC circuit. Even in the power electronics also we will be using only this equation. Got it? So completely whatever the mathematical part that is required from differential equations perspective for our network analysis, power electronics is only this first order differential equation. But we don't actually look at the variables or separables method or actually the homogeneous equations, exact equations, all those things we don't worry, because that is not anyway useful for us. We use only the first order Leibniz equation, that's it. So that's why actually we have to be aware of this and you need to master this. And then actually, so coming back to our discussion, what we have got is, so LdI by dt plus IR is equal to V, or di by dt plus I into R by L is equal to V by L. Now here, instead of P, it is R by L, which is a constant. Instead of Q, V by L, which is again a constant. Then the integrating factor in this case, integrating factor is e power integral P of x into dx. So instead of x, it is t. Instead of y, it is I. So that is R by L into dt, or this can be treated as e power RT by L. So this is the integrating factor. Now if you write the straightaway solution for this differential equation, and I into integrating factor is e power RT by L is equal to right side Q is V by L into e power RT by L into dt plus C. Now I into e power RT by L is equal to V by L is anyway constant, and e power RT by L integration is e power RT by L divided by R by L plus C. So this L and this L will cancel it out, and then actually I into e power RT by L is equal to V by R e power RT by L plus C, right? And this e power RT by L, if you take it onto right side, then I you are going to get as V by R plus C into e power minus RT by L. So this is, if you notice, this is a function of time. Got it? So this is how actually finally we arrived at the solution. So V by R plus C into e power minus RT by L, where C is an arbitrary constant. An arbitrary constant, right? And what is this arbitrary constant is, it can assume different values depending upon the initial scenario. So that is, it can assume a random value depending upon the initial conditions. Now let me explain what is this initial conditions. Now suppose, let us take two different scenarios. Let us take this one. So there is a switch over here and there is a resistance over here and there is an inductor over here. And this switch is connected to a battery like this, and this is how actually the circuit is there. Now this is R and this is L. So initially the switch was off. Then actually I turned on this switch so that actually it is flowing the current. Now in that particular scenario, the solution what we have got is I of t, we have got this as V by R plus C into e power minus RT by L. RT by L. Right? And then actually at t equal to 0, that means before the switch was on, or actually just about to switch on, what is the current already flowing through the inductor? Is there any current flowing through the inductor? Or actually in this circuit, is there any current that is flowing when the switch was off? Right? There is no current flowing. That means that's what we refer this as I of 0 is 0. That means at time 0, the current value is 0. This is the meaning of it. At time 0, the current value is 0. Now if I substitute here, so I of 0 is 0, and during that time V by R plus C into e power minus R by L into 0. So this is V by R plus C, because e power 0 is anyway 1 and this is I of 0 is 0. So C value we have got this as minus V by R. Right? C value we have got as minus V by R. And for this scenario of when there is no current traveling in the inductor when the switch is about to turn on. So that time this value is minus V by R. If you replace in the original equation, so I of t we will get for this particular scenario V by R minus V by R e power minus RT by L, or I of t we can call this as simply V by R 1 minus e power minus RT by L. So this is the current actually that is flowing. Now this will give you a beautiful relation. At any time you give me, it will tell you the current value. So at t equal to 0, the current value is 0. If you substitute t equal to 0, e power 0 is 1, 1 minus 1 is 0. Suppose at t equal to infinite, earlier actually we have discussed, that is during the steady state conditions, meaning the switch was on and waited for some time. So DC actually already reached its final value. Then when already it reaches the final value, inductor actually will not show its effect because actually the current flowing through it is constant. If there is a change in the current, it will react. There is no change in the current. It constantly flows 100 amperes of the current. Then in that case, actually inductor will not have any impact, whatever may be the current actually that is flowing through the inductor. And that you can notice at t equal to infinite, e power minus infinity is 0. So 1 minus 0 is 1. So V by R. As I said earlier, if the inductor is straight away shorted like this, then actually simply the resistance is the one which is acting. So V by R is the current. That's what exactly we are getting it here. So at t equal to 0 or at t equal to 1 microsecond, then you substitute t equal to 1 microsecond, depending upon the R value, L value, it will give you some amount of the current which will try to show that. So it will finally reach this value, but actually it will take certain amount of time and finally it reaches this current. So this curve actually, if you notice, this is the curve which shows that 1 minus e power minus RT by L value. If you try to draw the graph of it, so this is the one. And this value is V by R, and if you multiply with V by R, then actually it will finally reach V by R value like this. Got it? I hope you understood this. Any questions you can ask me. Is this understood? Right? And another case is, suppose actually we will take a different circuit. The circuit is same resistance, same inductor, same switch. But what I have done was, I have taken, there is one more switch left, let us say like this. And then actually there is one battery that was connected across this. Right? One battery that was connected across this. Let us say it is having a resistance of a smaller resistance, small r. Then actually this switch was on. This was off. So this was like this and this was like this. So this switch was on and this was off. Then we kept it like that for some time so that the steady state was reached for this. Then let us say this value is V0 and V0 by R. This value is I0, which is already traveling in the inductor. Then what I did was I turned on this switch and I opened this switch immediately. At the same time, if I open this switch and turn on this switch, then in that case, what happens is there is already current flowing in this particular circuit inductor. Then in addition to that, actually, this will try to drive the current like this. This was open now. But initially, there is certain amount of the current actually which is already traveling, which is equal to I0. Now, our solution, there is a resistance R here, there is an inductor here, and there is a voltage source of V. Then actually, what we get is L di by dt plus IR should be equal to V, the same equation. And you will get the same solution. I of t is equal to V by R. So I of t. Here actually you have to use the condition, that is V by R plus C into e power minus RT by L. But you should not be using 1 minus e power minus RT by L in this case. So this is not correct. And this one actually you have to use it, because this C value, as I said earlier, this is an arbitrary constant whose value is dependent on the initial conditions. Now the initial condition is not 0. So there is certain amount of the current that is already traveling. So that means what he says is the initial condition is I of 0 is equal to I0. Now if I substitute in this case, I of 0 is equal to V by R plus C into e power minus R by L times of 0 is equal to I0. Or C value is equal to I0 minus V by R. Now if I substitute this value in this equation, I of t is equal to V by R plus I0 minus V by R into e power minus RT by L. So this is V by R into 1 minus e power minus RT by L plus I0 into e power minus RT by L. So this is the equation actually what we are going to get as the current, and in this case this portion is coming extra because there is an initial condition. There is an initial current which is already flowing in the circuit. I hope you understood this. Any questions? Right? So this is the equation actually you notice in power electronics. In our network analysis, most of the times actually we will do only 1 minus e power minus RT by L into V by R. And this portion actually will take effect and it will be analyzed further in the case of power electronics. Got it? So the initial condition actually it will be deciding the arbitrary constant. So the original differential equation solution will not make any difference. The initial conditions will make the difference in the calculation of the arbitrary constant. That is the only thing extra. Got it? So is this clear? Any questions? Right? Okay. So if there are no other questions, I'm going to stop the class for now. In the next class, actually, we will discuss RC circuit also. And then actually, we will try to discuss the second order differential equations. Then we can move to the Laplace transform. So after that, we will actually start the topic. Got it? Yeah, that's all. Thank you.